subtracting and multiplying polynomials, there'll be a separate video on division. So a monomial is either a real number or a product of a real number with variables. These are also known as single-term expressions. Expressions lack an equal sign. So these are some examples of monomials. The number in front of the monomial is called the coefficient. So in this case, 8, -3, 7, and 9/17. And in these examples, 7, -13, and 1 are the coefficients. A polynomial in one variable is considered to be written in standard form when the degree of the terms are in descending order. So I'll show you guys some examples of that down here. The leftmost term of the simplified polynomial is referred to as the leading term when written in descending order. So in this case, you guys have, and I have to keep clicking the pen when I do this, so just bear with me as I go through this lesson. In this example, you guys have an exponent of 1 right here. Let me delete that. You have an exponent of 1, which means that your leading coefficient is 7x because that is the highest exponent. So your leading coefficient is 7, your leading term is 7x, and the degree here is 1, the highest exponent. We go from 2 to 1 to no exponent, so the degree here is 2. The leading coefficient is 5. -1 is the leading coefficient on this polynomial. We go from 5 to 3 to 2 to 0. So the degree here is 5. A binomial is a polynomial with 2 terms. A trinomial, 3. A linear is a polynomial with degree 1. So just to go back, a linear would be 7x plus 1. And a quadratic is a polynomial with degree 2. Write the polynomial in standard form. Find the leading term, leading coefficient, and degree. So in standard form, 2x plus 7. The leading term is 2x. The leading coefficient is 2. And the degree is 1. In standard form, 9a squared minus a minus 16. The leading term is 9a squared. The leading coefficient is 9. The degree is 2. -1/3 x to the 6th plus 8x squared plus x. The leading term is 1/3 x to the 6th. The leading coefficient is 1/3. The highest degree is 6. 2 or more monomials are like terms if they have the same variable parts with the same exponents on those variables. If this is the case, we can add and subtract like terms. So for instance, 8a plus 2a combines to 10a. -9xy and 5xy, same variables, same exponents, combines to -4xy. -6, 5x to the 5th y to the 2 minus 19x to the 5th y to the 2. So again, they have x to the 5th and y to the 2. -25x to the 5y to the 2. Last example here, -15st squared and -19st squared can be combined since they both have st squared. So we'll work out some examples of the same kind underneath. Again, you have to be mindful of what the operation is. So this is addition. The 3y and the 2y combine to 1y. The 11 plus 2 combines to 13. These are unlike terms, so they don't get combined. 9x squared and 2x squared is 11x squared. -1x plus 7x is going to be 6x. So we just keep the variable and add the coefficients. 8 and 13 is 21. 7x squared minus 1x squared is 6x squared. 6xy minus 10xy is -4xy. -2y squared plus 10y squared A 12y squared is 10y squared. In this problem, you have a mix of your variables, so my suggestion is to just go one at a time and then you can rewrite it in descending order at the end. So 4a minus a is negative 4a. I also like to cross out the terms as I use them. ab minus 6ab, those are like terms. Minus 2, there's no other constant, that's called a constant. And there's no other a squared term. You can leave your answer like this, but let's get in the habit of writing in standard form. So a squared minus 4a minus 5ab minus 2. Negative 13x squared, there are no other x squared terms. Negative 10 minus 2, those constants can combine. Plus 7x. Negative 13x squared plus 7x minus 12. Finally, some fractions, so I would get common denominators. These can combine together. They already have a common denominator. Negative 3 over 3t squared, which just is negative t squared. 3 over 3 is 1. 2 over 5t and negative 4 over 25t. So the common denominator there would be 25. You guys are responsible for knowing how to obtain common denominators. So that combines to a 6 over 25t. And then negative 1 minus 7 over 6. I can rewrite that as negative 6 over 6 minus 7 over 6, negative 13 over 6. Recall the additive inverse simply means to negate the terms. So the additive inverse of 8x minus 5 would be to negate the entire thing. So we get negative 8x plus 5. The additive inverse of negative 6x squared plus 8x minus 1 would become positive 6x squared minus 8x plus 1. So the additive inverse here, remember the additive inverse is just the opposite or to negate. All I'm doing is negating the terms by changing the signs. Additive inverse. We can use the additive inverse to subtract polynomials. One of the things I always suggest is just quickly negating the signs. So 12x minus 3 minus, so notice you have minus here, so that's why in the beginning I said be mindful of your signs. So minus. So what I like to do is I like to just write underneath what the sign should change to, and then you would just combine that way. So 12x minus 5x would give me 7x. Negative 3 plus 7 would give me 4. You can also do a change, so you would make the sign become plus, meaning the operation, and then you negate the signs, which is basically what I did up here. There are some worked out examples that I'll just walk you through. So 5y plus 3 minus negative 2y minus 7. So again, I'm just going to write what the new signs would become. This becomes minus, this becomes plus, and this becomes plus. Your final result. Again, minus in between would become plus, minus, plus, minus. So again, additive inverse. Then just combine. Not going to go through every combination, but you can always message me if you have a question about one. Here, same deal. So again, the operation is minus. So I'm going to go plus, minus, goes plus, minus, plus. And then I'm just going to apply these signs. Final result. And one more time, plus, so plus, plus, minus, minus, and combine. I didn't rewrite this one in standard form, but you guys would know that you would write in descending order. So 11, actually, I'm sorry, this is in standard form. Well, no, it's not. Never mind, I'll do it in the next example. Sorry about that. So here we go. Again, be mindful of your signs. You can pause the video to work them out and then watch with me after, or you can follow along. So it's 9x plus 2y plus x minus 11y, 10x minus 9y, negative 8a squared plus 3ab minus b squared. So again, this becomes plus, 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 minus. So we're going to have plus 3. I should have probably brought this down here. Let me move this. So, and I'll be mindful of doing this. So I'm going to bring that down. Let me erase this. Just so that it's not too confusing. So this will become plus, plus, minus. So plus 3a squared plus 6ab minus 11b squared. There are two a squared terms. Again, you know me, I like to cross them out. There are two ab terms. There are two b squared terms. S squared minus 5t squared. Actually, you can drop those parentheses at this point. I could do that after. So this becomes, right here, this becomes minus, minus, plus. So this is a minus 3s squared minus 8st plus 2t squared. There are two s squared terms. There are two t squared terms. And there is one st term. Our next example is to subtract one thing from another. So remember, you have to write this in the correct order. So whenever it says subtract one thing from another, this comes second. So we would write it as 3x squared minus 8xy minus 6 minus 4x squared plus 12xy minus 9. This becomes minus, minus, plus. So it's 3x squared, and of course this is plus. Minus 8xy minus 6 minus 4x squared minus 12xy plus 9. 2x squared terms. 2xy terms. Minus 15. Oh, I'm sorry, it's negative 6 plus 9, so that's positive 3. Let me just fix that little mistake down here. Sorry about that, guys. So this is a plus 3. Subtract 5a squared minus a plus 6. So this comes first. This is plus, minus, plus, minus. So the new problem is negative 9a squared plus 16 minus 5a squared. So I'm just rewriting those new signs. 2a squared terms, 1a term, and 2 constants. Another example. So again, minus plus. So the new example is n minus 3mn minus m plus 3mn. So n, these combine to 0, minus m. The rest of these are pretty self-explanatory. So this will become plus, plus, minus. So 7m plus 12m is 19m. 19m plus 7m is going to be 26m. So you could do it like that as well. And then 4 minus 3 is 1. 1 minus 8 is negative 7. You have to apply the new sign. The next one, so this is going to become plus, minus, plus, minus. Oops, didn't mean for, whoa, my computer's going a little crazy there. Sorry again. So let's go. 3b squared minus 9b squared is negative 6b squared. No other b squareds. This is 5b plus 12b, which is 17b, plus another 2b is 19b. And then 10, but it's now negative 10, minus 5 is negative 15. This will become plus, so minus plus. This becomes plus, so minus minus. 2x squared minus 2x squared just cancel. This is a minus 8y, I'm sorry for drawing over it, plus 6y, remember it's the new sign, so that's 14y, negative 8y, that's let me just check my notes, negative 8y plus 6y is going to give us negative 2y, and then negative 3xy minus 15xy is negative 18xy. So just be really careful when distributing those signs. Last operation is multiplication. So when you have a monomial times a monomial, these were already taught to you. These were in the exponent rules. So remember, when you multiply bases that are the same, you add the exponents. So we have 6 times 3 is 18. X to the 3 plus x to the 3 is x to the 6. And y to the 1 times, remember this is a 1 here, times y to the 8th is y to the 9th. Negative 7 times 7 is negative 49. A squared and a to the 1 is a to the 3. B to the 5 and b to the 4 is b to the 9. Here we're going to get a positive because two negatives multiply to a positive. You can reduce, so this is 2, this is 1. 4 on top, 5 on the bottom. X to the 7 and x to the 1 is x to the 8. Y to the 2 and y to the 4 is y to the 6. Z to the 1 and z to the 2 is z to the 3. 5 and negative 9 is negative 45. X squared and x to the 6 is x to the 4th is x to the 6th. Y to the 1 and y to the 1 is y to the 2. And there's only one z, so z to the 3. When it's a monomial times a polynomial, you will use the distributive property. 4a squared times 8a is 32a to the 3. 4a times negative 2, or a squared, is 8a squared. 5 times 5 is 25x squared minus 20x plus 10. Next one, C. 2y to the 3, 14y to the 2, minus 4y, 45, so this is p to the 7, q to the 3. 9 times 12 is negative 108, negative 9. P to the 5 and p is p to the 6. Q to the 3 and q to the 4 is q to the 7. So here's some examples about what I just showed you. Monomial times a monomial. Let me get my pen. Let's switch up the colors a little bit here. Let's go green. So we're going to have 10, because two negatives will result in a positive. a to the 6th, positive 12, x, remember I'm adding my exponents, to the 5. This thing gets so wacky on me when it doesn't need to. Sorry guys, here we go. 12x to the 5th, y to the 10th. Here, this can reduce to a 3 and this to a 1, this to a 1 and this to a 4. So I end up with 3 over 4, x to the 6th, y to the 8th. Now monomial times a polynomial, so we're going to use distributive. 18a to the 3, negative 12a squared b, negative 6ab squared. Same thing. 14, p to the 3, q to the 9, negative 21, p to the 4, q to the 9. This is a 9 here, by the way. And then negative 56, p to the 3, q to the 8. In this one, you have two distributions in f and g, so you're just going to do one at a time, and then combine like terms. 6x squared minus 3x, 7x squared plus 21x. So my like terms, there are two x squared terms, and there are two x terms. The next one, same thing. So I'm going to go underneath to give space here. 20y cubed plus 10xy squared. You usually like to go in alphabetical, that's appropriate. Minus 60y squared. There was a minus here, so just be aware of that. I know I kind of crossed over it a little bit there, guys, but just be careful. So you're going to have, let me just check on my notes to make sure that was negative. It was. So you're going to have a negative times a negative positive 10 x squared y minus 5x cubed minus 5x minus 55x squared. I don't believe there are any like terms here. No, there are not. So that would be your final answer. Last one, and I'm just going to move this down slightly just so you can see the numbers. So let me just grab that and I'll move it down. Okay, so here you have another distribution. It's actually three distributions. So you're going to have 18a squared minus 9ab minus 35ab plus 5b squared minus ab squared plus 2ab. I'm going to pause this and make a second video for the second part of this. So this is the first part of that video.